Okay, these questions. A satellite is in a circular orbit of radius r about the Earth of mass m, as illustrated in figure 1.1. The mass of the Earth may be assumed to be concentrated at its center. Show that the period t of the orbit of the satellite is given by the expressions. Okay, I have to show these expressions, where g is the gravitational constant. Explain your working. So when I ask you to explain your working, right, so we always put this: gravitational force provides centripetal force. So this is the explanation. That means the satellite moves in circular motion because there is a centripetal force. And centripetal force is the resultant force. So that is due to gravitational force. So we have to explain this. Okay, so we just said gravitational force provides centripetal force. So they just expect short explanation. So like this will be enough. You get 1 mark. Okay, now gravitational force gmm over r square. Centripetal force mr omega square. Okay, so cut the m on both sides. Gm over r square. R. Omega is 2 pi over period. 2 pi over period square. Okay, so we need to keep doing this until we get that equation, and it is not too hard. This is just some maths problem. So we expand first. Gm over r square equal to r times 4 pi square over t square. So t square equal to 4 pi r cube over gm. Okay, so that is the first part. Now B, a satellite in geostationary orbit appears to remain above the same point on the Earth and has a period of 24 hours. State 2 other features of a geostationary orbit. So state 2 more features. So you can say it is equatorial orbit. That means it's right above of the equator of the Earth, and the direction is from west to east. So these are the features. Now let's move on. Right hand side. Part 2. The mass m of the Earth is 6.0 times 10 to the power of 24. Use the expression in A to determine the radius of a geostationary orbit. So we know that geostationary orbit is the radius of the geostationary orbit is a fixed value. Okay, now we have to use the expression in A. T square equal to 4 pi r cube over gm. So t square is, the period must be 24 hours. So 24 times 60 times 60. So you square it. 4 pi r cube remain unknown. G is 6.67. 10 to the power of negative 11 times capital M, 6.0, 10 to the power of 24, count R, 4.23 times 10 to the power of 7. meter. Okay, so this is the answer. Now let us move on. The next part C. Okay, part C is about GPS. So a global positioning system, GPS, satellite, orbits the Earth at a height of 2.0 times 10 to the power of 4 km above the Earth's surface. Above the Earth's surface. Okay. So the radius of the Earth is 6.4 times 10 to the power of 3 km. Use your expressions in B part 2. Expression in B part 2. And the expression t squared proportional to r cubed to calculate in hours the periods of the orbit of this satellite. Okay, so they said use your answer in B part 2. Use your answer in B part 2, which is this answer. And you have to find the period. Okay, so t squared proportional to r cubed will give us an idea where, whenever there is proportional, whenever it is proportional, you can change it to equation by creating a constant of proportionality, which is k lah. So you create something like this, and k is a constant, right? So t2 over r cubed is a constant. Okay, so from here we can create a set of formula which is like this. If you have period 1 square, radius 1 cube, then it is equal to period 2 square, radius 2 cube. So we can create a formula like this. Because the left hand side, the fraction on the left is equal to k, the fraction on the right is also equal to k. So that's why we can create something like this. And you have to make sure we have two sets of information. So the T1 is this one. Okay, so maybe I put in blue. This is T1. So this one is R1. So we have T1, R1. Okay, T1, R1. And now we need T2. We need to find T2. So R2 is given. So what is R2 then? You have to know it in this way. R2. Let's say this is the Earth. The satellite is here. The GPS satellite. The GPS satellite. They purposely give you two information just to test you on whether you know the idea of R is from the center of the Earth. Okay, from the center of the Earth all the way to the GPS satellite itself. Okay, so where they give you two values, they give you the radius of the Earth, 6.4 times 10 to the power of 3, which is here to here. 6.4 times 10 to the power of 3. Then they give you here to here as 2.0 times 10 to the power of 4. So the whole distance is the R. Okay, the R2. So R2 is actually the whole distance. It's 6.4 times 10 to the power of 3 plus 2.0 times 10 to the power of 4. Okay, it's the whole value. And you make use of this and find T2. So now we just substitute. Okay, substitute. So here, T1, 24 times 60 times 60 square. R1, 4.23 times 10 power 7 cube. T2 unknown. R2 6.4 times 10 power 3, 2.0 times 10 power 4 cube. So work this out, find T2, you will get 42599.94925 seconds. Okay, that one answer in hours. So you divide by 60 and divide by 60 again, you get 11.8 hours.